Good morning, good afternoon, and good evening to everyone. Welcome to Atotech webinar about sustainable paint removal technology. You may wonder, why did Atotech put sustainable and paint removal in the same sentence? And I will explain to you the main need, the main benefit of sustainable paint stripping during this webinar. So let's start to understand the primary needs for paint stripping and what the different methods available today. So the paint stripping need are three main primary. The first one is, of course, something we cannot avoid. Every paint applicator has to bear this burden on his shoulders, is to do the maintenance and the cleaning of their fixture, jigs, and hangers to allow the production to continue to flow. So the second main need you may have also is going to take care of the defect and the reject part. So this is going to be very useful to save the money you have invested already to produce the part. Third reason, less common, is if you have casting defect, you don't want to contaminate the remelt, so you may need to remove the paint prior remelting the parts. So the primary method you have available today on the market are mainly mechanical, thermal, and chemical paint stripping method. So on all those three methods, you have every single method has some inconveniences. So mechanical paint stripping is the method to remove mechanically, physically, the organic coating from the substrate. So it can be different type of method applied. They are all belonging to the same family, like the impact, the grinding, sanding, media blasting, hydrojet to remove the coating. All of these methods have inconvenience. However, it cannot also avoid some damages to the substrate. You cannot remove the paint in a tight geometry. It can dull the surface. It's usually also pretty slow and labor-intensive method. The noise is a big concern, and proper PPE should be applied by the people. It's not also suitable for part reclamation in most of the cases, and the paint consumption, the paint collection is going to take time, so it's going to be very labor-intensive once again. The second method we commonly see has been developed to replace the slower method from the mechanical. So the thermal method is a way to use extreme heat. Sometimes also we have extreme cold to remove the organic coating. So the commonly named like pyrolysis, molten salt, fluidized bed. This is to break the bond and the adhesive with the extreme heat. And subsequent is going also to damage and weaken the parts. So what we can see, usually it's not avoidable, is to weakening the metal, the springs, and it's going to decrease significantly the lifespan of the parts. It can create also fire hazard. It can have an impact on your insurance policy. It's energy consuming, so usually even if the newest equipment are less energy consuming, is still consuming a lot of energy, and it will require a lot of maintenance. This high capital cost is also going to show a short life, so it would need to be replaced periodically every 6 to 10 years, maybe a little bit more for the newest version, more robust. Long process time because you need to strip, to cool down, and then you need to remove the hash. This is also one of the methods that can transfer and carry the most contaminant to your painting line and create also additional defect on the parts. The third one, which is an alternative to the two methods we just saw before, is chemical stripping. So the chemical stripping is a method to remove the organic coating by degradation and breaking the adhesive bond. Prior time is a function of the thickness to remove the paint and the type of the coating and the type of the chemical also you are using. So the typical method you use is a high-pressure solvent. It could be chlorinated solvent, phenol solvent, heated concentrated alkali, heated concentrated acid. So this method is usually pretty easy to implement, but it has some limitation. We need to pick it wisely according to the substrate we are going to process in it. It can generate a large amount of waste. It sounds to be cheap, but it will create a lot of burden in terms of maintenance and waste, and is also highly regulated, especially now due to the high vapor solvent or the chlorinated solvent and the HES risk. We have more and more regulation on this. The other downside of it is going to show a very, very quick slowdown in the strip rate, so inconsistency. Sustainable paint removal is a new alternative that is happening today to the market, is to create a process that will be able to provide additional benefits to all the prior technique we just mentioned. For example, if we are talking about mechanical stripping where we have a lot of labor, it creates damages to the part, sustainable paint stripping can really offer seamless operation. It could be safe to the part and the metallurgy, and it could be much faster than mechanical stripping. If we compare it to thermal usually you have very rusty parts, you have ashes and dirt and rust. So if you have sustainable stripping today, it can perfectly clean the surface at one pass. So the first pass is going to be perfectly clean, and it keeps the surface and the substrate intact. So this means you are going to also have a much higher quality compared to thermal. Sustainable paint stripping also can compare to chemical. If you have just standard chemical, where usually you use toxic and hazardous chemical, it's also very difficult to clean. You have a lot of dump, you have a lot of waste, and sustainable stripping has a main goal to have safe and fast to use. So it's a low VOC, low energy, long life, no damp solution. It's possible today with sustainable paint stripping. So if we think about sustainable paint stripping, it can also have a positive impact on more than one area in your workshop. So we will see how benefits can have this implementation in your workshop. First is reject reduction. So we not always think a reject could be created by poor stripping, but it's truly the case, because unclean rack could drag dirt and dust into the line. It can also create some altered geometry. So if you talk about a bumper and you put on the bumper rack and the geometry is altered, so the coating is going to be uneven and is going to create reject. It could also lead to a rupture from the hangers, so which is going to be more severe because it's going to stop the line, and after the line stoppage, you are going to have a long maintenance time to take care of it. If you use a fluidized bed, it's going also to create a lot of sand can be retained in some recessed area, and if you transfer it to your cleaner, it can very rapidly fill up the cleaner tank and lead to major issue to the painting line and the pretreatment line. The blasting bead also could be a problem, because if you have a spring-mounted jig, it can prevent to function properly and can create also some difficulty to hang the part properly. So the poor cleaning might also require extra operation, which could significantly and negatively impact the production yield. If you think also about sustainable stripping, it also can really help to optimize the grounding, because it's going to be much cleaner, much better quality of the surface, and the grounding is going to be improved. Poor grounding will significantly diminish the paint application performance. It can create uneven coating thickness. Some area could not receive paint at all, Like if you see on the photograph on the below on the bottom of this slide, you have just 10% of the part not covered at all. It can lead to extra operation to manually cover the missed area, and this will also increase the need for the higher consumption of paint. It will decrease the corrosion resistance performance, and it could also be more sensitive to breaking or peeling off. The coverage also could be not so uniform if you have dirty racks. With sustainable stripping, you will have optimum coverage for better paint gloss. You can have better curing. It's going to be optimized, so the curing process is going to be more performant. The coating will subsequently be more robust, and only minimal touch-up will be needed, so you also can save on the touch-up. Production will then be increased. It can also reduce the downtime, because damaged paint tooling support can lead to poor racking and losing part inside the washer, inside the paint booth, inside the curing oven, which is going to make it difficult to get the part back and to remove it from the line. So moving loosened part can also result in severe damage to the equipment. It can drag a part all the way along and can damage other pieces of the equipment. Line stoppage will then become a necessity. When equipment is damaged, stoppage for maintenance time risks to be extended. So it can, depending on the damage caused, it could be a very long time to take care and to return to the production. Also, you may have unavailability of some specific tooling that could significantly delay the production, especially for strategic parts, if you have limited amount of racking for this particular part. With a pretty clean surface, and you will eliminate all these problems. Sustainable paint removal also can have a positive impact on processes optimization. In this slide, you will see one of the benefits we not always see is related to the paint consumption. So if you consider unclean rack for just a small pieces of metal like a chair, where you need probably 6 decagram to paint one chair, then if you have unclean rack, it could require easily 8 decagram to paint the same unit. So it's an extra consumption of paint of 35%, which is not going to be all waste if you recycle, but it's still 35% and not going to the part, and you would need to consume extra. The hook coating rate also could very rapidly increase when it's not cleaned regularly. If you take a 1 meter long hook, and if you clean it every pass, it's just a few grams you have as a paint on it. But after 10 cycles only, it can be more than 4 kilos of paint on this very hook. So this extra paint accumulated will be 100% waste, with no possibility reclaiming, no possibility to recycle. So if you consider also the cost of the paint and the volume of the paint you are consuming every year, this can have a very big impact on your yearly spending for the paint. The jigs and rag handling also is going to be much easier when you use sustainable paint stripping. Aggressive paint stripping method usually create irreversible damage to the substrate. So then you will need to have heavy gauge steel, and it will be needed to prevent the racking to fail. So mean is going to be higher cost also for all these jigs, just to have the process running a little bit longer. The frequent replacement will also be a necessity. No matter what, maybe you can extend the life of this using heavier gauge steel, but it will require to be replaced periodically. Also, secondary operation is almost unavoidable, like realignment for the geometry, if it's damaged due to the heat for the impact, or if it's due to the transportation, The weld and the repairs would need to be addressed also. It can create also damage on the magnets. Some tool unracking are using magnets just to maintain the part in a proper position to make sure the painting is okay. So if you use burnout, for example, you are going to lose this and will need to replace the magnets all the time. The seals repair, the part replacement, such as the springs and everything. And also, if you have extra cleaning, you would need to clean the hashes, flakes, the dirt, and everything is going to be extra time as well. It's going also to impact the rack volume and the jig volume, all the tooling you would need to properly operate your paint shop. So if you use standard method, significantly extra jig volume and rack will be needed for the rotation due to the slow in-house process, or to send out to the contractor when you outsource this activity. It will also require for the routine replacement and also for the rotation due to the repair and additional cleaning. So this is usually a pretty significant cost if you consider you have a high production volume and you will need to have 3 times the volume of regular jigs and rack. Probably you can reduce this volume and save a lot on this jigs and racks building. It's also unavoidable to damage, so it will make the replacement a necessity. Smaller tools like the springs, which could be not processed usually with traditional method, stripping, can just be disposed because you maybe have no solution to efficiently strip that. So you probably use them a couple of times and then the paint buildup is too thick. So we just need to discard this part and we have no possibility to reclaim them. Energy consumption could also significantly be minimized when we are considering paint stripping, sustainable paint stripping. Sustainable paint stripping could offer drastically reduced energy demand. Some processes and product available today have very low specific heat. So this very low specific heat will reduce significantly the need of energy to take them to temperature. Also, those products are running at much lower temperature than conventional processes, which is going to be additional savings on the top. So when most available stripping method considered as a money pit, this type of sustainable paint stripping can really be considered as a money pot. So it can really help to reduce. In this example, you can see on the bottom, it's a reduction of 71% of the energy cost. So it's very significant. We also can have as a benefit very minimum waste and very long life to no dump possibility with this type of technology. So sustainable technology will offer a preservation of the solution and maintain it as it is optimal performance level. This means it's not only you are going to keep the solution for a very long time to almost forever, but it's also going to maintain the level of performance stable. So you are always going to have consistent strip rate, consistent performance in cleaning, which is going to be very helpful to predict and to forecast the operation. Long life solution will not only save money on the volume of the product for the makeup, but it will also save a lot of money and time on labor for disposal. You will not need then to clean the tank so often, to discard so much volume, and it's going to have a big impact also on the global activity. Generating as a waste almost only the volume of the coating removed from the surface. This means we are going to remove the powder with very, very minimum moisture contained, or we are removing the paint as a flake and it's going to be dry. So all what you are going to see as a waste is going to be only the coating removed from the surface. And as you can see here, this is how it can be achieved. With efficient technology, you can maintain the solution clean and 100% optimal. There is also additional economical benefits on the overall running cost. In this example, we usually see, oh, what is exactly my cost for paint stripping? Is it going to be the bill I pay when I outsource? Is it going to be the chemical I pay when I have it in-house? Is it the volume of media blast I'm buying to just replenish the equipment I already have? But if we take in consideration everything, considering the operation cost, considering the replenishment cost, this is compared to chemical stripping. And sometimes also it will appear a little bit not so attractive, because you say maybe the makeup cost is going to be a big impact. The makeup cost here, you can see on the lighter blue on the surface. And you can see here the difference with the conventional stripping, which is going to be an impact for sure. But if you look at the global situation, it can really help to reduce the total operating cost of the paint stripping. If you consider even the benefit after the second year, when the makeup cost is going to be over, because we are saying we have long life to know them. So you will make up the solution once and you will not need to do it ever again. This means if you compare to standard technology will be every year the same. If you go for sustainable paint stripping, after the first year, you will have only the replenishment, minimum energy, and you have also all the other additional benefits considering the transportation, the logistic, and everything. If you compare it to the cost per rack, which is going to be a pretty good indicator for you to track also your cost, if you compare to strip one rack, for example, with this chemical stripping method, every year is the same. You can immediately see with sustainable paint stripping on the first year, immediately the benefits coming. And it could be even greater benefits on year two when the makeup cost is going to be over. So this sustainable paint stripping will make every single part processing a fraction of the cost as compared to conventional method. The logistic cost also is going to be significantly reduced if you are currently outsourcing. So in-house stripping will allow very fast paint tooling turnaround with almost instant availability. So you will not need to have 1 week rotation to send to contractor, to strip it over there, to come back, then to have to take a secondary step, secondary cleaning, repairs, and everything. This tool is going to send in-house, be stripped very fast, and returning to the production very, very soon. So the damage and the loss risk is also can be associated with the transportation to the contractor. This will be totally eliminated. You keep it everything under control in your house, and you will not be dependent on transportation, contractor, and other third-party action. Expensive express transportation that may occur also when you are launching a new model, and is sometime you will need, you have a limited amount of racking for this special new model, so you would need to express it to have it rapidly available. This is going also to be eliminated since you are going to be capable of stripping in-house and immediately. Sustainable paint stripping, you may say, well, how do I proceed if I want to consider this in my workshop? So now we have solution very easy and very fast to implement. We have plug-and-play systems, and it's really ready to implement. So in-house stripping implementation could be as simple as connecting a unit to the power. So you order your unit, the truck is delivering to your facility, you just plug it to power, fill it with the chemistry, connect some water, and then you can immediately start. So the skid-mounted optimized installation, it's ready to use removal system, and it could rapidly be installed to save money at the same time and improving the working environment and the performance as well. It will ensure optimal performance, fast coating removal, low energy demand, and minimal waste. Everything is going to be designed to have these three targets in mind: to strip fast, efficiently, with a low energy demand, and with a low waste generation. Today, Atotech is making a significant stride promoting this technology, launching Master Remover Esprit, standing for Efficient, Sustainable Paint Removal Integrated Technology. This is a skid-mounted turnkey plug-and-play system. It will include all the features you need to have optimal performance and optimal paint removal. It's going to have heaters, agitation, specific filtration for you need, and is going to be ready to use. So it's going to be sustainable and safe to minimize the energy demand and the waste generation. You are going to have, with this unit, ready to use, ready to deliver in a short delay, you will have something that helps you to consume less energy, to have your rack very rapidly available, to also have very minimum waste generated, but also to be safe for the people who are working with the line. It's also going to be very easy to do the control. So if you have a complicated system, it's going to require very skilled people, but this process can very easily be implemented and very rapid to control. So it's rapid and easy activity level check. This makes the process always function in this optimal way. It's minimum water and additive required for a simple and easy replenishment, and also saving on water consumption. It's also designed to have an easy visual control to maximize the process simplicity of use. So if you have just to control is level of the product is correct, activity level is correct, and that's pretty much it you will need to be concerned about. It will really be a seamless operation that can save man-months just in a controlling and operating. So then I will introduce you a couple of case studies to also demonstrate the flexibility of Master Remover. So you will have you will see in this case study the possibility to use by spray, by immersion, offline, and inline for liquid paint and powder paint. So the first case study I'm talking about is OEM that have decided to use our technology to clean the skids, the tools, and everything. The first the first concern was to overcome the issue for safety, but also to realize significant savings. So they decided to use a very large spray cell that can take care of several car carriers at the same time, and also reduce the cost for the makeup. The full process cycle is operated without any operator intervention. You just load the tray enters automatically inside the chamber. Inside the chamber, it will be clean. Then after the cleaning is going to be rinsed. And only when the part is fully clean and rinsed, the door will open again, the tray will come out, and all the parts you have cleaned will be ready to go back to the production. And the elimination of the residue is going to be very minimal, since you are going to have like a dry residue, just as the paint flake you remove from the surface. It's also going to be minimal consumption and minimal waste for operating the process. The process in this case uses 60% water in the active solution and use the rinse water to top up the working solution to minimize also the quantity of waste you remove from the tank. The second example is to show also an OEM that has decided to use the same technology but in immersion for the tools. So this was also one more time to improve the safety. The safety was a top one priority for this account, and the savings were important, but safety was really number one. So a full study were made to determine which process could be the easiest and the most beneficial to positively impact the safety, but also to have the lowest running cost. So master remover by immersion was selected in this case because it was the safest alternative for on-site paint stripping. It was the most sustainable process, and it also showed the lowest operating cost. For example, at the same time, master remover has increased by over 60% the stripping capacity. So the speed of master remover helped to increase by 60% the volume of the part that could be stripped, making not necessary to outsource partially and to reduce also the quantity of jig and racks necessary to run the operation. Master remover also allowed to minimize the labor because it was simple and quick, and the overall operating cost for this example has been reduced by 57%, representing about $200,000 per year, which had a positive impact of reducing by $2.65 per car produced. The other benefit is no damage on the substrate and safe for the workers. So no damage for the substrate means we can use the same tools and jigs over and over again, and we don't need to worry about the worker's safety anymore. The savings just on energy was about 40%, representing a $4,000 per month also for waste savings, in addition on this savings on energy. So if you consider all this, it was a significant step forward for implementing sustainable technology in-house. The third one is to also show something that was not possible really until today. It's inline stripping. So if you look at these two photographs, you can see on the left side, it was offline, already in-house, with the standard chemistry. It was the performance you can see after 2 hours. This is how clean it was after 2 hours. So it was not really satisfactory. It was creating a lot of problem also for grounding, a lot of dirt. It was going to the E-code process afterward. So a lot of dirt and contamination also to the E-code. On the right side, what you see is the quality of cleaning we just achieved in 8 minutes. So now we are not talking about hours anymore. We are talking about minutes. Just this implementation helped to go from offline to inline, having not to touch anymore the racking and saving a lot of labor and maintenance and logistic and also storage space because of the need of the extra racks. So for this one, it's removing the 80 to 100 micron of E-coat plus wet paint in just about 8 minutes. We also at the same time implemented automatic filtration to maintain the solution clean. So no need for new makeup. This will minimize significantly the waste. This type of filtration can run for several years without changing the solution and then generating very minimum waste. So it's not going to require heavy volume to trash every year. This is for liquid paint, but we can also have a similar approach for inline stripping for powder. Master Remover has also in its portfolio a very, very fast powder paint technology to remove powder paint. So the paint stripping equipment in this case was already existing, but it was not really efficient and the design had to be improved. We were creating heavy operational difficulties to maintain the solution up and running, facing issues like a very short bath life, heavy sedimentation, poor filterability, and inconsistent performance, representing big challenges for this company to keep up with their high standards. So the volume of waste also generated was very high, changing the solution very frequently. So the implementation of Master Remover with very fast stripping rates allow to remove the paint every pass from those hooks in just 2 minutes. This means it was like not a long line, and every pass the hook is clean, offering very good grounding and very good contacts for this powder coating application. Maintaining continuously the solution clean also eliminates the need for the new makeup running on the same solution over and over again. Dry paint sludge also made very easy the filtration and the maintenance to reduce greatly the volume of waste. In this photo, you can see just one push of a finger to drop the sludge cake to have this as dry as this type of waste and to have the solution as clean as this continuously, offering very efficient and very stable performance over time. So this is what is today reality. You might wonder why it was not possible in the past. It was because of all of this I just explained before. The short life, the difficulty with the product, and everything. This is a new approach which completely changed the way of doing paint removal, especially paint removal in-house. So now it can be safe, and it can really improve the performance and reduce the cost of operating a paint stripping, which is most of the time unavoidable to run the process properly. So to make it short, to summarize, this technology has improved significantly and is changing on the market today. So poor tooling, cleaning could have many negative impact. It's not only one area we need to look at, but many negative impact. And if we want to have a global view, we need to look at all these areas. To get an accurate global cost view requires some time to look into hidden areas, even some unsuspected, like paint consumption, like reject rate caused and generated by the poor cleaning. Sustainable paint stripping can really efficiently support process optimization. So if you really want to improve your production, it's maybe one way that can support you in this operation. Technology have evolved and made significant strides towards sustainability. The old dirty paint stripping chemical or the burden of the burn-off, everything you already have in mind, it's not a fate anymore. Now new technology are available, are simple to implement. Change to superior solution could really be easy and fast to implement. Sustainable paint stripping makes it possible to combine also high performance and high cost, which was a real challenge until now. So hope this webinar was informative. Now we can go to the Q&A.
Thank you, Sylvain. We will now proceed with our Q&A session, and I would like to remind you all that we will cover as many questions as possible during our Q&A session, and all the rest will be answered by Sylvain after the webinar via email. Okay, let's start. Question number 1. We currently outsource our stripping. What steps would I need to take to bring a chemical process like master remover in-house?
So to bring master remover process in-house is pretty simple approach. So the first step would say is to determine what your need is. So we are going to collect samples, representative sample, to determine what process can fit best your need. And then we are going to make an evaluation to see if offline or inline could be a possibility. And after we collect also the information related to the volume of the rack you need to strip and a time you would like to allocate to this operation in-house, we are going to design equipment to fit your need and to supply you this equipment. So when this whole step will be over, you can just receive the unit, unload from the truck, connect to your power, and start using it.
Thank you. Second question, can this master remover technology be used for baskets?
It can be used for baskets. It depends if you are talking about cured paint and uncured paint. But both cases, it's just going to depend on what technology we are going to select. And then after testing, we will be able to provide you the best solution for your need.
Okay, thank you. Next question. I have an old burn-off system and I'm considering to just replace it with a newer oven that is more energy efficient. Can master remover be a more economical option?
What we have seen so far is every time we are running into making estimates, even if now it's true, the technology have also evolved for the burn-off and the energy consumption is much less. When we look on the overall running cost, it's usually always in favor of sustainable paint stripping. This is mainly because you will not need to replace the rig, the jigs and the racks. You will eliminate the secondary operation, and also you strip usually much faster than a conventional burn-off. So we need to make the calculation, and if you already have some data, it's going to be very easy and quick to go over it to see how much you can save by implementing master remover technology.
Thank you, Sylvain. There's a question on substrate. Can this product be used on painted plastic parts?
Well, this is not designed to remove paint for plastic. So the focus is really to remove from metal, light metal, not for plastic. It does not mean it's not possible. It's some area we haven't investigated yet, and we would require further testing.
Thank you. Next question. Can you explain more how master remover can be more energy efficient than other processes?
So it can be more energy efficient for the main reason we have a process and product with very low energy demand. So when we say we have low specific heat product and low temperature product, it's just to give you an example. Standard solution would need to be heated at maybe 100, 110 degrees C when we are talking about hot alkaline or hot acid. This is require a lot of energy because a specific heat is going to be twice as much as the specific heat of master remover product. Also, master remover product is going to work starting at 60 degrees C. So you are not going to save only on the energy from 60 degrees C to 90, 100 or 110, but is going also to require a lot less energy to heat up the solution at the same temperature.
Okay, thank you. What is the typical strip time for master remover compared to some of the conventional methods you mentioned?
So the conventional method, most of what we see available to the market, of course, is going to vary according to the paint thickness we need to remove. But typically, we are talking about several hours. In some cases, it could be a day, because if we have multiple passes, we probably need to dip the part in the solution and come at the end of the shift or at the end of the second shift to see if it's clean, and sometimes not really properly clean. With master remover, we are talking in some case just minutes. So if we are talking about one pass or 2-3 passes, it could be only 2 minutes to 10 minutes and is not going to require hours. If you are talking about a heavier buildup, we are just probably going to talk about 1 hour, 2 hours, compared to probably 8 to 10 hours with conventional process. Could be faster if you use a burn-off, probably it's going to be 2 hours, 3 hours, but then we will have additional time for the cool-off and for the cleaning. This, we are talking about just a short time, quick rinse, and ready to use again.
Thank you, Sylvain. Next question, what type of paints can be removed with these technologies? Are you familiar with the Magni or NOF metal coatings paints and dry film lubricants based on molybdenum? Which are the coatings difficult to strip?
So for this type of coating, we are talking about like a metal containing coating. And this is just going to be related to the process we select. So what we are going to do as every time we are going to run into a testing phase to select the most suitable process for your need. So we are going to try different processes to see which one is going to be the fastest and which one is going also to make the most economical sense. For now, I think only if you are using Teflon containing paint, most of the other paint, whether it's liquid, powder, e-coat, no matter the type of the paint, it's going to probably work in a similar way.
Okay, next question. How can a low-cost caustic stripper be more expensive to operate than master remover?
So when we talk about low-cost caustic stripper, usually we talk only about the purchase price per kg for this caustic. If you pay only a couple of cents a kg, yes, it appears to be very cheap. Sometimes it's a full bath we are going to make up. So if you have 10,000 liter, you need to buy 10,000 liter of this. Master remover, some of this could be only 60% water and 40% concentrated product. So first is going to be requiring a lot less volume of the chemistry. But also, if you consider hot caustics, is going to have very short life. And the energy is going to be one thing, but also it's going to start to slow down and to be not efficient. So it will require also a lot of frequent dump. And then subsequent is going to be a lot of cost for the waste. So it's not only the price you are going to do for the makeup, it's also the cost you are going to do for the cleaning of the tank. The people are going to clean the tank, the disposal to a facility that can take care of the waste. And all this volume is going to be very big compared to master remover, since master remover is going to be one makeup, and then you only have as a waste the coating you remove from your face, and sometimes rinse water a little bit.
All right, next question. Our company produces aluminium and zinc-plated parts. Can master remover help to reclaim our rejected parts?
Yes, actually, we also have processes, master remover processes available that offer reclamation for high-value parts. So this is going to work on aluminum, on zinc, or any light metal without even touching the surface of the part. So even if you dip your zinc-plated part, or if you dip your aluminum into the solution without paint for extended period of time, like 1 day or 2 days, you can look after on the SEM without seeing any change on the surface of the part. So yes, Master Remover is available also for high-value part reclamation.
Oh, thank you. Next question. Can I remove the E-coat paint from previously galvanized parts without attacking this galvanized?
Yes, it's related to the question just before. If you have galvanized part with a paint, E-coat or powder, or no matter what type of paint you have on it, the technology of Master Remover can remove the coating without touching the surface of the galvanized surface.
And is Master Remover affected by metals and phosphate or zinc plating under electrophoretic paint?
Well, this is going to have no impact on the performance. If you have some dissolved residue in it, it's not going to also impact the performance. And if you have solid residue, it's going to be filtered out. So we are not going to see a decline on the performance over time. If you have like a higher concentration of any soluble material in it, it's not going to impact the ability of Master Remover to remove the coating.
Thank you. Another question, is an exhaust system needed?
An exhaust system is required for ventilation. This is going to be a heated solution, so even at 60 degrees C, is not going to have a lot of vapor. So it's not going to require a very high system like a filter to have a VOC capturing or condensers like you can see on a regular paint shop. But ventilation, even indirect ventilation, will be recommended.
Thank you. Next question. How can you achieve a no-damp solution with Master Remover?
No damp solution is achievable for the main reason that we are going to keep the solution clean all the time. So we are not going to have the paint saturating the solution and keeping the solution efficient at the same strip rate and the same performance also over time. So we are going to design the unit to have the same the filter we need according to the paint we want to remove, automatic filtration. It could be many different type of filtration according to the way the paint is going to be removed from the surface, but then is going to keep the solution clean as new. So you will not need to dump the solution.
Thank you, Sylvain. Next question. We currently use media blasting for paint stripping. What would be the benefits of Master Remover?
If you compare to media blasting, one of the main benefits is consistency in the performance and also time. Usually it's faster. One other benefit is it can remove the paint totally from the surface. Media blasting, it's difficult to go to tight geometry, so some paint can be left on it. Then if you have some blasting media remain on the part or some paint chunk that not removed completely, it has also a risk to fall off when you are going to transfer to the painting line, which is not going to happen with Master Remover. So the main benefits over media blasting also is going to not touch the surface of the substrate. So you are not going to see any dueling on the surface. You are not going to see any damage or roughening of the surface. If you use media blasting, even for your hooks and your rack, what you can see after just a couple of passes, the surface is starting to roughen. And when the surface is turning rough, the paint adhesion increases. So the blasting is less efficient and is going to be taking more time and more time to clean it. With Master Remover, is going to be as fast from day one until the end of the solution life.
Okay, thank you, Sylvain. We are coming to the last question. You mentioned a long life bath. How can master remover achieve a longer bath life than other chemical methods?
The longer life is mainly achieved because master remover is a different technology, so it's very easy to filter. It's not that filtration has not been tried with other chemistry. It just sometimes the filtration is just not possible because of the nature of the chemistry. So the paint just dissolve into the solution and make it very, very hard to remove from the solution. Master remover is working different. We are not dissolving the paint. We are separating the paint and breaking the paint to have it into the solution, which is making very easy filtration. We have even process to remove powder paints that have a capacity to make a large flock of the paint inside the solution, which is going to be very easy to filter and also offering a very easy maintenance of the filter with the minimum dirtiness, and is going to be fast to remove. So all of this make it possible because the nature of the product is different, allowing high filterability, which is why you can extend the life of the solution.